So picture this. You are you're sitting in the final interview for your absolute dream machine learning engineering role.
Oh, the hot seat.
Yeah, exactly. The interviewer sits across from you, they slide a laptop over, and they just start a timer. And, you might be expecting to architect some crazy neural network or maybe write a really complex Python script. But you look at the screen and there is absolutely no Python.
None at all.
Right. There are no predictive models. There is just this massive SQL database and a blinking cursor.
Which is terrifying for a lot of people, but honestly, it is the ultimate gatekeeper in this industry.
Yeah.
Because, I mean, the cold, hard reality of machine learning is that your model only knows the data you actually feed it.
Yeah, it's just a reflection of the data.
Exactly. SQL is the filter that decides what data gets through in the first place.
Mhm.
You could, understand backpropagation perfectly, but if you fail that initial SQL screening, you never even get the chance to show off your AI skills.
Right, they won't even let you touch the models. So, we are calling this the anchor problem for today's deep dive. Here is the exact scenario you're facing in that interview chair. You're handed a single table, and it's just called users.
Okay, pretty standard.
Yeah, and you need to find all the users who meet 3 strict criteria. 1, they are from India. 2, they are strictly over 25 years old. And 3, they signed up after January 1st, 2022.
Okay, so I want you to put yourself in that chair right now. Before you even think about typing out a single line of code, how are you solving this? Think about the underlying architecture of what's actually being asked here.
Right, like what's under the hood.
Yeah. Which specific columns matter? What conditions have to evaluate to true? Just try stating the exact logic you need in plain English.
Welcome to the AI and ML YouTube channel by 60 Seconds Academy. Here, we focus on practical and application-based understanding and concept clarification so that you can be industry-ready and apply your knowledge to real industry projects.
And, to get you industry ready, really have to look at the raw material you're working with here. So imagine this users table conceptually. In a relational database, every single row represents one individual user, right?
Yeah.
And every column represents an attribute of that user. So we've got an ID, a name, an age, a country, and a sign-up date. And let's say there are 8 specific users we are looking at.
Okay, 8 users. Let's name them so we can track this. We've got Amit, Sarah, Raj, John, Sneha, Alex, Priya, and Sam.
Perfect. Now, most of the time, looking at a table like that is pretty straightforward. You have users from different countries, different ages. But in an interview setting, they never, ever give you perfectly clean data.
Oh, never. They always plant landmines.
Exactly. For example, what if you have a user, let's look at Sneha, who has a name, a country, and a sign-up date, but her age is just, it's completely blank.
Or like Sam, where maybe his country is missing entirely.
Right. Those missing pieces of information, those are called NULL values. And they are extremely intentional traps designed specifically to test your fundamental understanding of databases.
They just want to see if you trip up.
Oh, 100%. Yeah. But before we even try to navigate those specific traps, we actually need to completely rewire how you approach the coding problem itself.
Yeah, the mental shift.
Exactly. Because if you are coming from a standard software engineering background, like using Python or C++T, you are deeply, deeply conditioned to use imperative programming.
Right, imperative, meaning like I am micromanaging the computer.
Yes.
I'm giving it step-by-step instructions on exactly how to execute a task. Like if I'm using Python to solve our anchor problem, I am definitely just writing a for loop.
Yep, the classic loop.
Right, I would initialize an empty list, and then I'd say, computer, go to row 1, is the country India? If yes, check the age. Is it over 25? If yes, check the date.
Yeah.
And if all of those are true, append this user to my list.
Right.
And then I literally have to manually tell it to move to row 2.
Exactly. You are controlling the entire execution path. But SQL fundamentally does not work that way.
Right.
SQL is a declarative programming language.
Yeah.
You do not tell SQL how to find the data. You only tell it what data you want returned.
Okay, let's unpack this mental shift because honestly, it's massive. If I'm thinking about imperative Python, it's like I am walking into a gigantic grocery store or warehouse.
Okay, I like that.
And I am personally walking down every single aisle, picking up every single box, checking the label against my requirements, and deciding whether to put it in my cart, like one by one. It's a loop.
It's exhausting just thinking about it.
Right. So what is the SQL equivalent of that?
In SQL, You never even set foot in the warehouse aisles.
Right.
You walk right up to the front desk, you hand the warehouse manager your highly specific declarative shopping list, and you say, bring me exactly this.
Oh, wow.
Yeah, you just let their internal, highly optimized systems locate and retrieve everything simultaneously.
Okay, I see. So the database engine basically takes care of the how or completely behind the scenes.
Precisely. You have to lock in this mental model. SQL works on the entire table all at once. SQL does not iterate. SQL filters.
It filters. Got it.
And that is exactly why stating your logic in plain English, like, give me rows where country is India and age is over 25 and sign up as after 2022, is the absolute vital first step.
Yeah.
If you start trying to build loops in your head,
Yeah.
you've already failed the interview.
Because you're speaking the wrong language, conceptually.
Exactly.
Okay, so now that we have that declarative, manager at the desk mindset locked in, let's actually build this query step by step. Let's translate that plain English into actual SQL syntax.
Let's do it.
So the very first thing I need to do is tell the manager which warehouse to look in, right? So I start with select from users, and the asterisk is just like a wild card that grabs all the columns, right?
That's your foundation. You have established the raw data set. Now you hand over the first requirement on your declarative list.
Okay, requirement 1, where country, India. So my code is select from users where country, India.
Now, notice what happens conceptually to the engine right here. Data instantly collapses.
Like it just shrinks.
Yeah, the database doesn't care about users from the USA or the UK anymore. They are entirely dropped from the working memory. You are down to a specific subset.
Okay, so step 3, I need to stack the next condition. This is where basic Boolean logic comes into play. I need them strictly over 25, so I'm going to use the AND operator. Select from users where country equals India and age 25.
You're narrowing the funnel even further.
Yeah.
Now lock in the final constraint to complete the query.
Right. And Andy sign update 2022-0101. So my final submitted code is select from users where country India and age 25 and sign update 2022-0101.
Boom.
So let's say out of our entire conceptual data set of 8 people, only one single user, let's say Raj, who is 28 from India and signed up in November 2022, makes it through all 3 gates. I found the right data. I passed the interview, right?
Not quite yet.
Wait, really? Why not?
Knowing what data successfully passed the filter is only half the battle. If you are dealing with a senior engineering interviewer, they will immediately ask you to point to a specific rejected row and explain the exact mechanical reason why it failed.
Oh, right. Because understanding the rejections proves you actually know how the logic engine works.
Exactly. They want to see your thought process.
Okay, let's test this. Let's imagine our user Amit. He is 23 from India and signed up in 2023. If I am the engine, I check the age condition. 23 is not greater than 25. That statement evaluates to false.
Yep.
And since the A&D operator requires all conditions to be true, the entire row is dropped.
Perfect. What about another user? Let's say Priya. She is 27 and from India.
Okay, so Priya is 27, so she passes the age check. She is from India, so she passes the country check. But let's say she signed up in December 2021.
Right, before the cutoff.
Yeah, that's before our January 1st, 2022 cutoff. That evaluates to false, so she is dropped. But here is where it gets really interesting. Let's go back to those edge cases we talked about earlier.
The landmines.
Yeah. Sneha. Sneha is from India. She signed up in 2023, but her age is completely blank. It is a NULL value. How does a computer evaluate a blank space against the number 25?
See, this is the exact clarity the interviewer is probing for.
Yeah.
Most programming languages use standard Boolean logic, true and false. But SQL fundamentally uses 3-value logic.
3-valued.
Yeah. True, false, and unknown. An NLL value represents a state of unknown.
Okay, so when the SQL engine checks Sneha's age, it's literally asking the question, is this unknown value mathematically greater than 25?
Yes. And the engine's answer to that question is not false.
It's not.
No, the answer is unknown. But the golden unbreakable rule of the where clause is that it only keeps rows that evaluate to strictly true.
Well, I always say it's...
Since unknown is not true, Sneha is filtered out and dropped.
Okay, understanding that mechanism, like why a row drops, that makes perfect sense. But it naturally brings up a bigger question about how the SQL engine actually processes that block of text behind the scenes.
It's a great question.
Because when I wrote the code, the very first word I typed was select, then from, then where.
Right. And reading top to bottom, left to right, is a very human way to process information. But you are not a human in this scenario. You're an engineer talking to a compiler. The database engine does not read your code the way you typed it.
Right, really?
Yeah, the true order of execution is completely different.
It reads it out of order.
Always. The engine's true order of execution starts with from, then it executes where, and select is actually executed last.
Seriously.
Think about the physics of data processing and why architects designed it this way. An engine cannot possibly filter rows until it knows which specific table it is opening. So from has to happen first to load the user's table.
Okay, yeah, that makes sense. It needs the raw material first.
Exactly. Then it immediately applies your where filters to shrink that massive data set down. It operates like a funnel. You want to discard irrelevant data as early in the computational process as possible to save processing power and memory.
Got it. Chunk it down fast.
Right. And only at the very end, once you have your tiny subset of winning rows, does the engine look at the select clause to format the exact columns you want handed back to you. Select is just the formatting stage.
Okay, I understand the funnel concept, but what does knowing this execution order actually mean for the person sitting in the interview hot seat? Like, how does this trip people up?
Well, if you don't deeply understand this order, you will fall into the alias trap. It's one of the most common reasons candidates fail at technical screening.
Oh, man. Okay, let's explore that trap. Say I am writing my query, and I want to make the output look a bit cleaner for the end user. In the very first line, I decide to rename the age column to userage.
Sure.
So I write select age as userage from users. And then down in my where line, I want to use that clean new name. So I write where userage 25. I mean, it reads perfectly.
And the engine will instantly crash and throw an error.
Wait, seriously? Why?
Trace the true order of execution we just discussed.
Oh.
What runs first?
From runs first, it loads the table, then where runs, oh.
You see it?
So the engine hits the line where userage 25, but it hasn't even looked at the select line yet.
Exactly. The engine looks at the string userage and says, I have absolutely no idea what this is. That alias does not exist in the engine's memory during the where phase because the select phase hasn't happened yet.
Wow.
If you write that in an interview, you are immediately signaling that you don't understand how compilers process data. Execution order is non-negotiable.
That is wild because to a human reading the code, it looks flawless.
Yeah.
You really have to think like the machine.
You really do.
And now that we know when the filters are applied in the sequence, we should probably talk about the specific tools we use to build them.
Yeah, we call this the row filtering pattern. Whenever an interview prompt starts with a find all the users, get the records, or show me, you are instantly deploying this architectural pattern.
And the toolkit for this pattern has to be, more than just greater than or less than mathematical signs.
Oh, it is much broader. You have the between operator for inclusive ranges, like finding users between 20 and 30 years old.
Okay, handy.
You have the IN operator for specific sets, like finding users in India, USA, UK, without having to chain a bunch of OR statements together. And you have the like operator for text patterns, such as finding a name like S% to grab anyone whose name starts with an S.
Those are super powerful tools. But I actually want to go back to those missing values, the NLs, because this is where my imperative programming brain wants to take over again.
Let's hear it.
Put yourself back in that interview chair. You are tasked with finding all the users who have no age listed in the system. If I type where age equals NL, will that work?
I'm very glad you brought that up. The answer is definitively NL. It will fail.
Why not? I mean, in Python, if I want to check if a variable is empty, I check if it equals none all the time. It's standard practice.
It is, but SQL NL does not mean 0. It does not mean an empty text string. As we discussed with the three-valued logic, NLL means unknown. It is a completely missing state of information. If you use a mathematical operator, like an equal sign, you are literally asking the database, does this completely unknown concept mathematically equal this other unknown concept?
And what does the database do with that?
It evaluates the comparison as unknown. And since it is not strictly true, the filter fails. You will get 0 rows returned, even if there are thousands of missing ages in your database.
Okay, so if the mathematical equal sign fails, what is the correct syntax?
You must use the state operator is. The correct syntax is where age is un.
Oh, ISON.
Yes. This asks a fundamentally different question.
Yeah.
It asks the engine, is the state of this data officially unknown? And the engine can definitively say, yes, that is true.
Okay, I think I have a sneaky workaround for this whole logic problem.
Oh boy.
Let's look at the country column. Let's say my task is to find everyone who is not from India. Simple enough. I am going to use the universal not equals operator. I write where country, India. That is going to give me all the USA users, the UK users, and it should absolutely give me Sam, whose country is NULL, because an unknown country is obviously not India.
That is a brilliantly logical human assumption. And if you use it, you will completely compromise your data set.
Wait, how does a simple not equal sign compromise the data?
Go back to the three-valued logic rules. The engine evaluates Sam's row. His country is NULL. You are asking the machine, is this unknown value not equal to India?
Yeah, and it's not.
You, as a human relying on context, assume an unknown thing probably isn't India. But the machine is rigidly logical. It says, I do not know what this value is, therefore I cannot mathematically guarantee that it is not India.
Oh, wow. So the statement evaluates to unknown.
Yes. And because it evaluates to unknown rather than strictly true, Sam's row is dropped. By using the S operator, you unintentionally and silently filtered out every single NUL value in your entire database.
That is genuinely terrifying. Because if I am tasked with pulling data for a machine learning pipeline, and I just casually use, I am quietly dropping a massive chunk of data without a single error message popping up.
Exactly.
Yeah.
Which brings us perfectly to the physical connection between these SQL mechanics and the real world of machine learning engineering. We really need to pull back from the syntax and look at the physical infrastructure of your system.
Let's do it. How does all of this connect to the hardware?
I want you to visualize your infrastructure. Your SQL database lives on your disk storage. It is an ocean of data. Disks are designed to hold massive petabyte-scale amounts of information safely.
Right, the ocean.
Now, your active working memory, your RAM, which is where Python, Pandas, and your ML models actually live and compute, is just a small bucket.
Okay, so let's pose an advanced scenario based on that. Imagine your data set isn't just 8 users. It is 10 million rows of user telemetry data. Your task is to train a model on a specific subset of that data. The imperative Python part of my brain says just pull all 10 million rows into a pandas data frame in Python and write a script to filter out what you need there.
If you try to pour the entire ocean into the bucket, what mechanically happens?
The bucket overflows, my system completely freezes up.
Exactly. You hit a fatal out of memory error, your notebook dies, and your model never even starts training. This introduces the concept of time complexity.
Okay, how so?
Well, if you try to scan 10 million rows one by one in Python, that is an ON operation, meaning the time and memory required scale linearly with the amount of data. It locks up your active RAM. But SQL databases have highly specialized, optimized engines built specifically to execute that exact ON scan across the disk incredibly efficiently without overwhelming the system.
So the absolute unbreakable rule of data engineering is you must always filter at the source. You filter on the disk using SQL before loading the tiny, refined subset of data into your Python RAM.
Always. And this right here is exactly why ML interviews hammer SQL so relentlessly. They aren't just checking if you memorize the syntax for a select T statement.
They're checking if you actually know what you're doing with the hardware.
Yes. They are checking if you understand system architecture. If you try to pull 10 million rows into Python just to filter down to 100,000, you are showing the interviewer that you don't understand memory limits and you don't understand how to scale a production system.
Okay, we have covered some serious ground today. I want to summarize this entire session into a mental pattern card that you can just keep in your head for your next interview.
Let's lock it in.
All right, the pattern name is row filtering. Your goal is to extract rows based on specific conditions. The core mental shift you need to memorize is moving from imperative programming to declarative programming. You are describing what you want, not micromanaging HW to get it.
And the order of execution is critical and non-negotiable. It's from the table first, where the conditions act as a funnel to shrink the data, and only then do you select the columns to format the output.
Right. And the common mistakes you absolutely must avoid: do not use mathematical equal signs with NLL. Do not ignore the execution order by using formatting aliases in your where clause. And do not fall back into loop-based thinking.
To really test if this new mental model has clicked, we have pulled 4 common variations of this interview test. We highly recommend you visualize the query construction for each. Level 1, find all users from India who are exactly age 30.
Level 2, find all users who are not from the USA and who signed up in the year 2023. And be very, very careful with how you handle those NLLs.
Level 3, find all users where the age is explicitly missing from the dataset.
And finally, level 4, find all users whose names start with the letter S and who signed up before the year 2022. Mastering those 4 levels will officially solidify your SQL foundation layer. This declarative mindset is going to be the reference point for all future data manipulation you do. But before we sign off, I want to leave you with one final thought to mull over. We established that SQL is the ultimate gatekeeper that efficiently filters the ocean of data before it ever reaches your ML model.
Right.
But think about the trap we discussed with the CompTIA operator silently dropping unknown values. How might poorly written, logically flawed SQL queries not just slow down your computational pipeline, but actively skew the statistical distribution of the very data your AI learns from?
It is a sobering thought.
Yeah.
A predictive model only knows the universe of data it is allowed to see.
Exactly. If your SQL filter accidentally drops an entire demographic just because their telemetry data was formatted differently or left incomplete, your highly advanced AI is going to be fundamentally blind to them and you won't even see an error message. The foundation matters, keep building it, and we will catch you on the next deep dive.